Hey everyone, section 1C.3, stem plots. Tons to write on this slide, but you don't need to write all of this. In fact, I wouldn't write any of this except for these couple little lines in bold down here. And I don't even do this with 4 steps. I do this with 3, but you can customize this the way you like. So let's just talk through this, what a stem plot is. A stem plot is different from the next plot we're going to do in section 1C4, which is called a histogram, probably something you've seen before, but kind of tricky to make by hand. A stem plot shows us every single data value, but sometimes rounded and sometimes in a very weird way. So it shows us with these things called stems and leaves, hence the name stem plot. So my steps are really going to be, let's make our stems, then let's add our leaves. The textbook does this extra step of ordering the leaves. I order the leaves as I go, but for some people that's tricky. So we'll do it the textbook way for this one. And then we're going to add a key. So let's look at what all of that means. The easiest way to understand this is with an example. I think if you're looking at all these words, it's overwhelming. So let's go right into an example. So here we have resting pulse rate in BPM, beats per minute, of 19 middle school students. So this is something we could easily do in class one day. We can just say, all right, everybody, just measure your pulse and I'll keep time, all that stuff. Here we want to make a stem plot. So when you make a stem plot, the first thing is to figure out your stems. Stems are typically the leading digit. So in this number 71, your stem would be 7. But really, your stem isn't quite the leading digit because if you look at 104, it wouldn't really make sense for it to be the 1. It would have to be this whole 10 down here. So instead of thinking about the leading digit, which is what the textbook tends to call it, I want you to think about place value. Here, our stem is really the tens place. And if you have a bad understanding of place value because, elementary, middle school was plagued by, I don't know, COVID, that's all right. But we want to think about the stems as our tens place. So here it will be 7. So this 7 really means 70. And let's just focus on the 7 before we go any further. Let's find everything in the tens place of 70. So I'm just circling everything with the 7. This is sort of the way I do it. I usually don't circle it, but I want you guys to be able to see what I'm talking about. Everything with a 7 is going to be sort of relocated onto this row here with a 7. And the way the textbook will do it, and so the way we'll do it, we're going to write them in one by one. So I started with a 1. That's this 71. Then I put a 6. That's this 76. Next, I have a 78. I'm just going to stick an 8 there. 71 is a 1. So again, it's important to really notice, this is sort of awkward, but what is going on here? This 1 is 71. It's that guy. Next number, we've got a 70, a 74, and a 76. If that kind of made sense, great. There are 5, 6, 7 values in the 70s, so our 7 row has 7 things. If you have no idea what just happened, rewind, check that out again. If it's still not clicking, be like, Mr. Young, what even is a stem plot? Call me over, I'll help you out. They're a little weird at first. All right, flash forward. Here's that same 7 row that we had, but we filled everything else in. It's worth, once you do this, maybe go through and count everything, make sure, hey, did I get them all? Right? There's 19 things. Count, make sure you have 19. But there they are. From there, we need to have these guys in order because the order matters. So there's 2 different ways to do this. I'll give you the textbook suggestion and I'll give you my suggestion. Here's the textbook suggestion, which if you haven't figured it out already, I'm not very good at hiding my opinion. I hate. They write everything out, then they rewrite it and order it. So they take this 7 row and say, the 0 should come first, then a 1, then a 1, then a 4, 6, 6, 8. And they reorder it and completely rewrite it. The easier thing to do is to reorder your list of data at the start. And if you're like, that's not any easier, I promise it is if you've got a graphing calculator. And if you do have a graphing calculator and you want to learn how to do some stats on there, we are going to do that in class. But whatever method works for you. So we're going to reorder everything. Cool, we're almost done. Except there was a fourth step that was add a key. I'm going to write it here in my janky handwriting, but we know it's going to look nicer on the next slide. So add a key. The key tells us what is going on here because this 6 right here, I don't know if that's 76. I don't know if that's 0.76. I don't know if that's 7.6 million. I also don't know, is that $7.6 million dollars? Is that 0.76 pounds? So that's what our key is going to tell us. And your key is really simple. They wrote way too much here. When I do a key, I'm literally going to write key and I'm going to put a colon, just like they did. They were off to a good start. And then I usually pick any number. Um, don't pick any number because some of you will look at this data and you'll pick a silly number and I'll roll my eyes because we're not in middle school. But I would like you, typically I just pick the first number and I'm just going to write it as exactly what it says there, 6/8. And I'll write 6/8 equals 68 BPM, right? Give it units so we know what we're talking about. They give it the full context. A student whose resting pulse rate is 82, 8/2 is 82 beats per minute, whatever. If you write this for your key, that is our minimum that we need for credit. Okay, so before you keep going on, make sure that that stem plot thing makes sense because we're about to make it a little more complicated with a second type of stem plot. So here we see one where things are a little bit bunched up. So what we can do is something called splitting the stems. So let's just focus on this 22. This 22 has a pretty long stem. It's kind of hard to see the shape here. You can always turn your head to the side and look at shape. It looks kind of roughly symmetric, but sometimes when we break it down further, we get more data. So I'm going to break that 22 stem into two different stems. That's what a split stem plot is. We split stems into two stems, which means 5 numbers have to go in each one. So this one's going to get all of 0 through 4, and this one's going to get 5 through 9. Sometimes we think 0 to 5 because 5 is like the halfway point, but 0 to 5 is actually 6 numbers, so don't do that. 0 to 4 and 5 through 9. So in my stem plot, these guys, oops, if I could write 0, 2, 3, 4, they're going to become one thing, one row. And then 5 and above, and notice I'm spacing them here, so it's like I'm on a grid. If you have 4 numbers in one row and 4 numbers in the next row, uh, they should take the same length. We don't, though. We have 7 numbers here. So this will tell me a little bit more about shape. Let's go one step further and have the whole thing done. So there's my 0, 2, 3, 4, and my this guy, 5, 5, whatever. We've split the stems. Our key hasn't changed. We didn't have a key before. This is about head circumference. Um, so if you're like buying a hat, but notice in this first one, it kind of looked roughly symmetric. But now when we get over here to this one, it's maybe a little bit more skewed toward this higher value. Or maybe it's a little bit roughly symmetric. And this guy's actually an outlier. It did not look, 25.6 did not look like an outlier. But we went from 24.2 all the way up to 25.6. And that, when we see it on a split stem scale, or if we looked at a dot plot, we would see that's actually a pretty significant bump. Notice that there's nothing here. There's nothing from 24.5 to 24.9. There's nothing from 25.0 to 25.4, but we still have to have them there, right? They're part of our scale. That's like our x-axis, except it's vertical, so maybe it's like our y-axis. Okay, here's our pause practice play. Let me just quickly say, I was nice here and I gave you a stem plot. The homework's going to ask you to make some stem plots as well. Making them's a little tricky, so please talk to me. Bring me over, be like, Mr. Young, How do I figure out my stems? The first couple times you do it, it can feel a little tricky. But give it a pause, try this one, and then hit play. All right, really, this problem just wants us to interpret a pre-made stem plot. It tells us the largest data value is for main, and it asks what's going on with main. Okay, cool. That literally just means let's find our largest value. That's going to be here at the end. We've got to go to our key, and it tells us 19/3 is 19.3%. So 20/6 would be 20.6%. What percentage of Maine's residents are that old, or what is it, 65 or older? 20.6%. Then we want to make another stem plot by splitting our stems. This one just gets long. 11, 11, 12, 12, 13, 13, 14, 14, etc. Am I going to have enough room? We need two 20s down at the bottom. Okay, and then remember, we're just splitting by, is it 0 through 4, or is it above? So 1 and an 8 are going to go like that. There's nothing in that next row. 12.6 would go there. 13.9 is going to go in our second 13. 14's got a 2 and a 3. Then we're skipping, right, because there's nothing here. 15's going to get 4, 4, 4, 4. And we're at 5, 6, 7, 7, 8, 8, 9, 9, 9, 9. This one's pretty easy because we're really just recopying and thinking about, does this number go in this box or not? 5, 5, 7, 9. You can see how fast I'm doing this. Let's give a pause. Sorry, I said let's give a pause. I didn't mean for you, meant for me. I paused my recording so I could just fill in the rest of the answers because it's boring just watching me write all that. All right, so I remade the key, or remade the stem plot. The key doesn't need to change. The key is still the same. We can just pull that old key over. But what do we see now? That's sort of the bigger question. That's the interpretation. That's what stats is all about. We can see that not only does this have a really weird um, sort of shape, it's got this odd like skew on the bottom, but we can see that on the lower end, it's really spread out and that there are gaps, right? We call these gaps. We can see there's this fairly decent pattern from like 15 up, but that the left side is really spread out with these awkward gaps there. All right, you know the drill, guys. Be sure to like, follow, and subscribe and all that garbage. See you next time.